So, yeah, the topic for the webinar today is from ground to sky, that is exploring careers in aviation. So, just a brief background about myself. I have completed my bachelor's in electronics and communication engineering from BMSIT, India, Bangalore, and followed by master's in systems engineering from ISA Toulouse, that is in France. And I also did a couple of certifications. One of them was in digital transformation, which was a distance program from MIT Sloan, and the most recent one was Advanced Space Systems from IISc Bangalore. And with this, I gathered about 15 years of work experience in aviation, which is in aerospace and airfield and airport management systems, which is mainly air traffic management, and also in the test and measurement industries. So I also gained lot of rich international experience, I would say, by working in three continents and many countries. So worked across Europe, Middle East, US, and also, yeah, Asia. And through my work experience, I have a lot of hands-on experience in safety critical systems throughout the entire V model, that is in systems engineering of aerospace systems or airport systems. And in addition, I'm also a tech enthusiast and a blogger. So I write many articles and I also have my own newsletter. So the agenda for today is aviation career options. So I'll start off with this, and then I'll provide a brief introduction to systems engineering, because I believe, being a systems engineer, I believe this perspective is important, and it's not covered in most of the courses of engineering or elsewhere. And I'll also give you a brief overview of simulation and testing, which is quite unique to aviation field, followed by aircraft systems overview and career paths, airport systems overview and career paths, airline systems overview and career paths, and followed by digital transformation and future trends and how to prepare a career for this in this lastly. So first I'll start off with aviation career options and why to pursue them, followed by introduction to systems engineering and overview of simulation testing, which is unique to aerospace or aviation field, followed by aircraft systems overview with their career paths, airport systems overview and their career paths, airline systems overview, career paths, followed by digital transformation or the emerging technologies, and lastly, how to prepare for a career in this. So coming to aviation career options. So aviation, as I see it, it's like three main categories. So first you have aerospace systems where you build the flight itself, the systems which go in building up the aircraft. Then you have airport, which is used basically by aircrafts and for global connectivity. Then you have airlines, which operate aircrafts in order to ensure the global connectivity. So why aviation? First of all, I would say that human beings have already been uh, fascinated by flight, the concept of flight. So it's a very aspirational field, and it's very inspiring to see people fly and push boundaries with supersonic or even the commercial and military flights which we have these days. And it's a very multidisciplinary field. You have a lot of disciplines which are interacting. So one of the physics, you have electrical, electronics, software, mechanical, uh, all these fields merge, and it's really interesting to see the result. These are also mission critical systems. So each aircraft is assigned a mission, whether it's carrying passenger or carrying cargo or whatever it is, even if it is just for a research purpose. And The environment which this aviation operates is very dynamic. So you have like weather changing always, you have regulations changing always, you have geopolitical tension. So you have to keep adapting to this changes. Then going to the safety oriented, so it's a very safety oriented field. Safety is paramount, I would say, and air travel is one of the safest means of travel. So the accident rate is very very less compared to any other means of travel, and it's also highly regulatory in nature. So you have a lot of regulatory authorities certifying the aircrafts, and it's a very hands-on field, I would say. You have to like just get in and get your hands dirty, because you'll have to pay attention to each and every small detail of everything it's done, because the safety, if the safety is compromised, the impact is huge. And you also have a global workforce diversity and interdependence. By this I mean you have lot of career options. You have like meteorologists, system engineers, mechanical engineers, you have operations, everybody interacting with each other. And it's also global, so they can be from different nationalities. And then you also have this concept of like aircrafts landing in other countries, and they have to interact with the air traffic controllers from other countries. So it's very interesting to see this global workforce diversity. And what we have seen is, in spite of limitations such as COVID or geopolitical tensions, the demand for this field continues to grow. So I would say, if you're choosing a career in aviation, this would be the one of the best time. And you also have a lot of technological advancements, so it's one of the best playgrounds for innovation. So once I'm done with my presentation, there's a Q&A session. If there is any questions, please feel free to ask. Okay, jumping to the key skills and education. So the main thing I would say is, like, you need to have a system perspective. You need to understand systems, because how they interact with each other, and you need to get like a holistic perspective, because nothing is independent here. You cannot think in silos. You have to think system wise. Like, if you are an engineer, you have to think, how do I talk to air traffic control, how do I talk to operations, how do I talk to maintenance, because everything is interdependent on each other. And you also have diverse career paths. So like I said, you have in operations, engineering, maintenance, and you also have like meteorologists, a lot of specialists. And this is a specialized, you need specialized skill set. By this I mean, you might need to get some certifications, like for safety, for example, or anything which you want to specialize in. If it's like aerodynamics, you have to have that kind of skill set, and you need to know that set of tools. So this is apart from your degree which you have pursued. And based on the dynamic nature of this field, you have to keep learning continuously. So if, for example, if the regulations keep getting updated, you will have to update yourself and get a certification, or just stay up to date. And there are also other kind of skills. So like, you need technical skills, of course, that is no doubt. And you have communication skills. So by this I mean, there are a lot of stakeholders. So you have operations, you have air traffic control, you have maintenance, for example, all these in an airport, and you have engineering. So you need to be very clear and crisp in your communication, so there is no ambiguity, and there is no room for error, basically. That's why there is a lot of importance on communication skills, whether it's written or verbal. And problem solving skills, of course, because there's a lot of troubleshooting which will have to be done in case of any errors or any incidents which occur. So this is one of the key skills which is required. Educational background, coming to this, so I would say you don't need a degree in aerospace engineering. I mean, if you have it, well and good. But otherwise, even if you're an electrical engineer or electronics or mechanical or software, You can easily adapt because there are a lot of diverse career paths, as I mentioned. You can adapt according to your whims, or you can also be a system engineer, which is kind of like a which gives you a holistic overview of the whole system itself. So, coming to systems engineering, so I would say that it's an interdisciplinary approach to defining, analyzing, and managing complex systems. So, whenever there's a problem which is complex, like you have to build an aircraft to carry passengers from A to B, so you will have to have build a system which has like a there's an air component, then there's a ground component, and there are also many parties interacting on the ground with the air. So it's a very interdisciplinary approach, I would say, and that's why we have this framework, which is systems engineering. And for this, you have to have system thinking. So as you can see, the picture itself is self-explanatory. You have a lot of components interacting with each other, and also not to forget the humans, which is also a very complex uh, entity by itself. So, and this has a lot of career opportunities, so I'll take you through this as well. In the end, you have a lot of fields, not only aerospace, you have other fields as well, such as space. And this framework is governed by international organizations such as ISO and INCOSE. So introductions to systems engineering, just continuing this. So here the stakeholder involvement is key. So by this I mean like each of the perspectives of the stakeholder matters, and each of their requirements have to be documented so that the system is built by taking into considering everything like a holistic perspective. And you need to define the problem before implementing the solution. It's like a problem which is well defined is problem half solved. So, firstly, focus on defining the problem and then jump to the solution, because you might have a lot of technologies which are tempting to be deployed, but the thing is you'll have to focus on the problem itself, define the requirements, and then see which technology or which architecture uh, will be a resolution to the problem. And you also have this divide and conquer. So modularity is always there in system engineering. You will have software requirements, hardware requirements, firmware requirements, all of them separate. And lastly, you will connect the dots. This is one of the main roles of system engineering, which I will explain in a bit. So it ensures traceability. So this by this you have this V model. This is one of the most famous models of system engineering, which is like where you define the concept or the use case, like carrying passengers from A to B. Then you have system requirements, which are then divided into high level design, detailed design, or preliminary and critical design, followed by their implementation in software and hardware. And then for each of these phases, you have testing. So for concept of operation, you have system validation. For system requirements, you have system verification. So each of them has a separate plan for testing, so that the acceptance or the system validity is guaranteed, and followed by operation and maintenance, and also changes and upgrades. They're also managed within the system life cycle itself until the system itself is retired or replaced. Okay, so coming to simulation, so what I can say is it's a safe environment. So this is one of the unique features of aviation I would like to highlight, or aerospace. You not in every field you have this simulation, because and it's a very important step, and it's a mandatory step as well. So, what is simulation? So, you might have seen this flight simulator, and for sure, I mean, you would have seen at least games with flight simulator or the real flight simulator images or videos. And you also have similarly, you have also airport simulators, which simulate scenarios in the airport. So, they're really important, and you have some engineers just to focus on them. You have engineers building them, you have engineers testing them, operating them. So I would just take you through the advantages of simulation. So, the first thing is it offers a safe environment for training and skill development. So, all the pilots or air traffic controllers, they can train as much as they want and on various scenarios. So, it's safe and nothing is impacted on the real time or in the ground. And then you have easy access. So, you can just go, and whenever it's free, you can just interact with the simulator based on the setup. And you can create a lot of weather and terrain scenarios which are very critical to aviation. Also, you can test some new systems features or like prototypes, like you can just do some software changes or hardware changes, and you can test because it serves as a quick test bed, where you can, it's like a fail fast method, fail fast, fail safe method. And crisis management training, which is very important in this field, is also available in through simulation. So people can, pilots or air traffic controllers or just even ground staff, everybody can just practice how to handle situations such as emergencies like low visibility or in case of fire or uh, any emergency scenarios actually. And it also aids in analyzing operational efficiency. So this point, it's mostly relevant to airport because in airport you have the airport simulator where you have the live traffic coming in. The live traffic is fed into the simulator, and you can analyze like how many aircrafts per hour your runway is able to handle, and you can see where the changes can be done, like if you want to add a terminal or a taxiway, or how to manage, or if you have to add a runway, or maybe you need to add other controllers. So it's a very good test bed to analyze this, and it also aids in airport design and planning, just like I said. And one of the main advantage of simulation is reduces emissions because it's not a live environment, and also operational costs. So imagine if you have to test something in the real environment, you lose a lot of money, and also the emissions are high. Coming to testing, so testing you have this is just a brief introduction. So you have the process like verification. So it means did you build the product right? So you have some system requirements, then you have your test plan where you verify according to the system requirements. So that is the key line, like did you build the product right? It's basically depending on the system team who build the product. And validation is, did you build the right product? So did you build what the customer asked for? This is the kind of acceptance testing we say in this system engineering terms. So there are a lot of types of testing. So you start with the components, and then you go to integration, then you go to system level, then acceptance. And when it comes to aircraft, you also have some parts which undergo endurance testing. Like you need to ensure that this part is operating for like 10,000 hours or uh, something like that, until the MTBF. And you have some preliminary tests to ensure this. And regression testing is something like if you make some changes or upgrades to the product or patches, you need to ensure that the functionality which you changed is not affecting the original functionality which the system was built for. So these are the basics of testing. And yeah, I want to come to why am I giving such importance to simulation and testing? Because it gives you exposure to the whole system life cycle. If you're like designing a system, it's just you design, and after that I don't think you will look further. But when you test it, you need to understand the system requirements, you need to understand the user requirements, you need to understand the design, and then you need to design the test case accordingly and the test equipment, which is very crucial here. So that's why I say it gives you exposure to the whole life cycle. And you need to think creatively, of course, because you need to think better than the developer or the person who implemented the system in order to find bugs or errors. Critical thinking as well. And customer advocacy. So the testing engineer or will be the final, or even the simulation engineer in some cases will be doing the final testing with the customer. So you have to ensure that the customer is satisfied, and if they're not, you need to understand some take some hints from the customer, and then give it back to the design team or the requirements team. So you're kind of the link between the customer and the system team itself. That's why I think it's a very interesting profile. Okay, coming to what is aerospace. So now we'll be jumping into those three parts which I mentioned before. That is the aerospace, airport, and airline. So we'll be going through them one by one. So what is aerospace? So it's a branch of engineering concerned with design, development, production, testing, and maintenance of aircraft and spacecraft. So here, let's talk about aircraft. So you have three main fields, that is like aerodynamics, structures, and systems. So my focus will be on systems. While aerodynamics and structures are also really good career profiles, you can also take a look at it separately. So, overview of aerospace systems. So, in this, you have, I've just tried to list the main aircraft systems actually. So, one of them is flight control system, which is mainly used for controlling the flight, then flight management system, where you have the flight plan and the flight path and basically the guidance, and communication and navigation system to communicate with the control towers or area control centers. And navigation is to follow the route map actually. And engine control system for making sure the engines are operating well. And landing gear system, of course, to land the aircraft. Environmental control systems, so to ensure the pressure, temperature, everything in the aircraft is uh, ideal. So these are just a very small overview of systems. There are much more systems like traffic collision avoidance system. So you have a lot of them. These are just the basic ones, just to give you an idea. And these are the career paths. So you have system engineer, of course, and you have software developer, system development engineer, testing engineer, avionics engineer, which focuses mainly on the avionics or the cockpit part. Then you have data analysis engineers, which analyzes the data from the flight and see if there can be any improvement, or if there is any predictive maintenance or corrective maintenance required. And of course, you have researcher. So these are research options. I mean, there are a wide array of research options in aerospace career field. So you can choose any of them. So just one thing, I'm like in this webinar, I'll be focusing only on the engineering professions. Also, there are non-engineering professions or non-STEM professions such as law, marketing, finance, and aviation, which will be addressed separately. So the aerospace sector overview. So in this, you have the aircraft manufacturer as the main, like Airbus, Boeing. Then you have system integrators. You might have heard of Honeywell, Collins, or sorry, Northrop Grumman. Lot of system integrators, and you also have regulatory bodies. So the system integrators itself will have a lot of suppliers. That's why I put supplier one, two, mix. So this is basically the overview of how the sector itself is organized. And these are like examples. So first one is an example of test rig which was built for testing one of the aircraft parts. As you can see, you have a motor on both sides, and then it has to drive this actuator, as we call it. And there should be, this setup has to be designed and built, and software has to be designed and written for this itself. This is just for testing purpose. It's not going to be operational and put on the flight. I mean, the motors, just the part will be put. And this will also be sent to a production facility once you ensure that this works okay and this test rig is testing it the right way. It will be sent to a production facility. So, for example, if Etihad places an order for 100 A350s and you need to manufacture 100 of these parts, and each of them will be tested in this test rig. Each of them will be having a report which is generated at the end and saying whether this part is okay or not okay, and action will be taken accordingly. And the picture on the right you can see is the cockpit simulator, which is or the flight simulator where you can simulate a lot of scenarios for the pilot to work and exercise on. And lastly, the one on the bottom you can see it's called the Iron Bird. Basically, this is taken from Airbus Toulouse. So you have all parts of the aircraft which are coming from different parts of the world, and they're being assembled in one facility, single facility. So it will look like this. It's called an Iron Bird. I just want to give you the importance of criticality or the software and the hardware which goes into aerospace. So it's you have five levels A, B, C, D, E. So first one is catastrophic. So if you say that you have a catastrophic error, it means one of the main systems like flight control system or engine control system or terrain avoidance, one of them is in error and it would result in multiple fatalities or the loss of the aircraft itself. Basically, it's like scenario for an aircraft crash. Then you have B, which is hazardous. So you have significant impact on safety, but still not necessarily catastrophic. So if you lose any of the primary systems, so secondary systems are still there. And then you have major, where you have major disruptions to the aircraft, but not necessarily compromising on safety. So maybe your secondary systems are gone, but you still have primary. So that's why it's called major. Then you have minor. So there are some minor descriptions or inconveniences, like if an in flight entertainment system is not working or passenger Wi Fi, and some of them have no effect. So where you have this cabin lighting system or the internal intercom which is not working, so it would be classified as no effect. So each of the hardware and software will be designed according to these level of criticality, or they're called safety assurance levels in other terms. And just to give you an idea of the famous disasters which have happened due to ignorance, I would say, or confusion or lack of communication. So, and that's why the safety is very important. So, first one would be the Tenerife airport disaster, which occurred in 1977, which was due to the miscommunication and misunderstanding between air traffic controller and the flight crew due to this dense fog. So that's why I say communication, even if it's in verbal or English, it has to be clear and crisp so that there is no confusion even between the air traffic controller and the pilot. Or even so I would like to highlight that there should also be good communication between the vehicles and the air traffic controller as well, even if it's like within the airport itself. And okay, followed by Ariane 5 launch failure. This was, I would say, this was because of a copy paste error which occurred, and the software which used a 64-bit floating point number which exceeded the system limitations. As a result of that, you have this guidance system failing, and the rocket launch itself failing. Then you have this Air France flight 447 crash. So this was a combination of factors. Usually, none of these failures should be a single point of failure. If it is, it's a really bad design or execution, I would say. So this flight failure happened because of bad sensor, which was covered by ice, and there was a lot of confusion among the crew, and it was aircraft went to stall, and it was impossible to recover the aircraft. So by these, I think you can understand the safety critical levels and why this amount of safety is going into this field. Okay, coming to airport sector overview. So you have lot of stakeholders in airport as well. You have the airport authority, you have ATC, you have operations, safety. Then you have a lot of airlines which also interact with the airport authority, like they take permission and um, for fueling, for parking the aircraft, and for operating it basically. And you have a lot of regulatory authorities as well. You have like regional authority, you have national authority, international authorities. Then you have also a lot of suppliers. So it's a very diverse field where you have a lot of stakeholders just interacting and building one system. Giving an overview of the airport systems. So you have Airfield Surface Movement Guidance Control System. Its acronym is ASMGCS, which has various levels actually. It has a lot of components like surveillance, routing, lighting, and conflict management. So this is one of the latest systems which is used across some key airports in the world, which can tackle low visibility and harsh weather conditions, and also while improving the operational capacity and efficiency as well. It's a very interesting field which I have worked on it myself. And airfield lighting system. So you might have seen the lights on the aircraft once you land on the runway or you take off from the runway, mainly at night. So this is a very complex system by itself, even though it's just lights. And ground surveillance system, of course, very important. It's always very crucial to know the position of the aircraft, like almost the exact position of the aircraft, as long as it's within the toleration limits. And approach surveillance system as well. It's critical to know the position of the aircraft in air as well. And instrument landing system, mainly used for landing. It's also called as navigational aids, which is also a very critical system. Meteorological system, of course, we need the weather update. It's needless to say that it's the one of the most important ones. um, Visual guidance docking system is used for parking the aircraft, and just also while takeoff for pushback. And airport operational database is a database which combines the data from various systems, and it will have parameters like the exact pushback time or the taxi time and the takeoff time, all these, and from which stand, and what is the flight plan, what is the destination of the flight. So it's also really interesting, and it's purely software. And flight information data system, display system, is the one which you've seen on the airport. Like you see the list of flights and which gate and what is the status. Building management system is again the overview of the airport itself. So it gives you an overview of the terminal and like all the facilities. Basically, if there is any fire alarm, you will be alerted, and whether some facilities operating or not operating. Basically, all the power substations and everything is monitored by this. Again, this is a very brief list of systems. There are other systems also which are in airport, but I just chose these because they are important for air traffic management and also ground at the same time. Then you have airport systems testing. So the first picture you can see on the left is it's an airport simulator where you can simulate various scenarios. Like you can see a lot of aircraft parked. You can choose how many aircrafts and where they will be parked. You can also choose what weather conditions, like if it's a dust or low visibility or storm, rain, and how many controllers. You can choose that, and you can close some taxiway or runway and just just play around with it for testing and training purposes. And this picture on the right is typically how the systems look like in the tower. Like you have cabinets, and each of them is nicely arranged within a cabinet, all the servers and the screens. And below you have this runway which is showing the lights. So usually when you do the testing on the field, there is somebody in the field uh, to check the lights. So there's always a field component when it's associated with airports, because you have to confirm that the light is on the field, the right light is on the field in the right brightness and under the right settings. So all these are very crucial. Coming to airport career paths, you have system engineer, of course, and system development engineer, testing, ATM engineer, that is air traffic management, special systems engineer. By this, I mean all these CCTV cameras and all the building management systems, which I said, all the low voltage ones. And you have surveillance specialist, which takes care of all the surveillance components. So you might have seen the surface movement radar, which is circling in the airport, and then you also have multilateration, which is another method of surveillance, and you also have GPS. So all these will be combined, and the surveillance or the track or the position of the aircraft will be conveyed to the pilot in a visual means. So you need a dedicated engineer for that. And then you have airfield lighting engineer, who ensures that the light which is switched on from the controller is switched on in the field in the right way. So you have a lot of systems in between, I would say, and a lot of components just for one light to be switched on in the field, which is really interesting. And you also have research, a lot of research options in airport as well. You can research regarding the capacity or the operational efficiency or the noise, or I mean, lot of options again. And sustainability specialist, I put this because usually this is the trend and also need of the hour now, because you need to ensure that your airport, and even when it comes to airline, you will be seeing the same thing, that it airport complies with the regulatory environmental regulatory conditions, basically. So the noise is within the correct or the tolerable level, and it's not the airport is not built in an endangered species area. It's not encroaching any area which is of environmental importance. And each of these power systems and all that have to be viewed with this angle, sustainability angle. So uh, recently it's all promoted to use renewable energy. And yeah, I think this is also a very interesting role which was gaining some traction. Airline systems, coming to this, so this is again a brief list of airline systems from an engineering perspective. So you have flight operation system, which is the dispatch scheduling, which is also built by software engineers. And you have fleet management system, so you manage the whole fleet of the airlines. Um, and fuel management system, just to monitor and control the amount of fuel. Crew management, to maybe to have rosters and for the crew and manage their schedules. Check-in and boarding system, of course, which is widely used by the airport, so, but each airline will have them separately. Customer relationship systems, such as like loyalty management, and all these come under this category. Ticket reservation and booking system, which is yeah, which is evident, and it's also very crucial one, because also pricing and revenue management comes into this. In-flight entertainment system is also specific to every airline, cabin management. So the airline can customize the aircraft as it wants. So that's why I say cabin management is also and in-flight entertainment is uh, unique to each airline. Cargo handling system and also how they handle their cargo and how they handle ground. And finally, you have predictive maintenance. So you can have with AI and data analysis, you can have a predictive maintenance, corrective maintenance system for the airline itself, for the whole fleet. Coming to airline career paths, you have a ton of them. Firstly, it's the aircraft maintenance engineer, I think, which is one of the most common one. Aircraft performance engineer, which also checks the performance um, of the flight itself. Flight operations engineer, flight data analysis engineer, which analyzes the data and sees how uh, it can, with those insights, you see how it can be improved if there is some areas of improvement. Software developer, for sure, and navigation and route optimization engineer. This will come into picture when you are have the ticket and reservation system as well, and flight simulator engineer. So yeah, you said there needs to be somebody who's maintaining the flight simulator and updating them as required. Systems engineer, of course, if you want to have a whole perspective. Digital transformation engineer is mainly um, because each of these systems is undergoing a digital transformation of late in the past decade. So there's a lot of focus on this, and this could be a dedicated role in some airlines, and sustainability specialist as well, since air travel is also contributing to the CO2 emissions. They see the industry is also trying to move towards sustainable aviation fuels, or SAF, and a lot of places where or like even when it comes to catering using eco-friendly material, all this will come into picture, and sustainability specialist will have to take care of this. And certification engineer, this is also very important because the aircraft has to be certified with the regulatory authorities, and it has to go through a process. Just deviating a bit, I want to introduce you to digital transformation, which is also a concept. Uh, you might have already heard of it. It's also a buzzword these days. Firstly, there is digitization of data. So, usually, in the previous decades, the data used to be like in analog form, or sometimes even like it could be in a paper format. So, it was being digitized. So that is digitization. Then digitalization is like you digitalize the whole process. Once you have the digitized data, you will digitalize the whole process, and then you have you create like um, you adapt it to your business needs, and that is called digital transformation. Which you will see that the future trends are all dependent on this process. So just going through some of the future trends, or even some of them are even current. So let me put it this way: you're moving towards electric aircraft, and not the conventional fuel or fossil fuels. That is one of the. It also comes under sustainability, I would say. This is a nice field to be interesting field to be working on. Then you have digital twins. By this, I mean like you have a digital twin of the aircraft itself created, and you can analyze which part of the aircraft need to be updated, which needs to be uh, modified or tested. Again, it's like a simulator, but it's a digital twin in essence. And autonomous systems, yeah, it's also moving towards autonomy, like where there is unmanned or some parts of the aircraft is going to be like autonomized, like something like that. And you have advanced air mobility, that is eVTOLs. We will come to that in the coming slides. Augmented reality. So this is a concept which can be used in the flight simulator, where you see uh, the aircrafts in a very AR kind of way. So you have also the real digital world interacting or interfaced with the physical world in this. Artificial intelligence, of course, has numerous applications, needless to say that. Remote monitoring and diagnostics. So there is also a connectivity among the aircraft systems which is being enabled and strengthened so that you can do some remote diagnostics. 3D printing is another field which is taking off. So you have some of the parts being 3D printed, which is an interesting way, and it also saves time, and it also takes into consideration the kind of materials, and it's being done in manufacturing already, and robotics as well, like robots are also employed um, for the aircraft manufacturing. Electronic flight bag, this is also a concept which is also already in being. So you had a lot of documentation before, and it was in the cockpit. So you have a lot of manuals, a lot of flight plans, and everything was in paper. Now we're moving to like an iPad kind of uh, uh, tool, which is just you just open this iPad and then you search for what you want, so that it's very quick. Yeah, there's also weight reduction in the aircraft by the paper. You don't need to skim through lots of tons of paper to get the answer for what you're looking for, mainly for pilots. Coming to future trends in airport systems, so you have smart airports. Everything is being hyper personalized and contactless, mainly to satisfy the customer. You have virtual or remote towers, which are also coming to trending like slowly across airports. You have automatic routing. So this is another important concept. So once the aircraft lands on a runway and goes to a stand, um, I mean, once it lands, it the system will already propose a route so that it goes to a stand automatically. The controller just has to say okay, and if he doesn't like the route, he has to modify it. So this is one of the unique and advanced system concepts which is coming into the airport system. So it's already operational in airports across, I think, a few airports across the world. Sustainability as well, as I mentioned, vertiports to manage the eVTOLs. We'll come to that. Digital twin of airport as well, which is very interesting. Biometric systems also in the terminal. Augmented reality for the tower simulator. This is again interacting the physical world with the virtual world. Artificial intelligence to analyze and improve the efficiency of various systems. Remote monitoring again to enable connectivity between the airport systems and aircraft systems. Data sharing and interoperability also for the same. So coming to advanced air mobility. So this is what I meant by eVTOLs and your vertiport. So you have advanced air mobility, which is a field. So system engineering is really important for this because you have unified, scalable, safe solutions. And in this, you have two categories. One is urban air mobility and regional air mobility. So in this urban air mobility, you have uh, these kind of air taxis, which are uh, being built for cities, like for smart cities, or whenever there is a plan to improve or relieve the road traffic. And they're safe, autonomous, and they're also sustainable. So this is one of the interesting fields which is coming up. And also, regional air mobility is not only confining to the city, but you extend this to the suburbs and rural areas. So, mainly the purpose would be traffic relievement in the cities or medical evacuation in case of emergencies or cargo delivery, where you have drones carrying packages, and then you have disaster response. So this basically is, I think you would have already seen this, like in case of fire or earthquakes or floods, it's really useful. So you have AM career paths. So basically, you have aerospace engineer who concentrates on aerodynamic structures and the overall perspective of the design of the aircraft. Then you have avionics engineer focusing on the cockpit part. Then you have battery or energy systems engineer, because this is one of the key uh, concepts of electric taxis, or these air taxis which we are seeing. And system engineer, you have human factor specialist, because when you these are being designed and they're also evolving at the same time, so you need somebody to have this perspective of human factors. And there are also research topics like autonomy, sustainability, and aerodynamics. So you also have the researcher path even in this. And I think it's one of the best paths to take on right now, because you have a lot of it's still nascent and evolving, this field, so it's really interesting. And I would like to highlight also UAVs, so the drones, which you might already know. There's also a ground control system, and there's a communication link between the drone and the ground control system. And use cases are civilian, commercial, research, and military and defense. So mainly these are used for a wide range of purposes. Like in civilian, it's used for uh, like all these disaster relief and medical emergencies. For example, for commercial, you already have the delivery of packages by Amazon and those kind of things. For research, you have for like environment monitoring, so monitoring of the air, for the just for the environmental purpose, to track the global climate change parameters, for example. And military and defense has a lot of purposes for UAVs. And also in civilian, I would like to highlight that there's a lot of drones being used for agriculture and all these fields, uh, just to just to improve the efficiency or the quality of this crops, and also to plant crops. All these use cases, I mean, there are like hundreds of use cases which cannot be specified in one slide alone, but it's a lot, just to give you an idea of these use cases. And UAV career paths, so you also have aerospace engineer, systems engineer, and you have mission planner, because you have the mission for each drone might be different. Like you even have photography and videography these days. Flight test engineer, and then you have the drone pilot or UAS pilot. Field support engineer, because there's always a field component which has to be checked. Data analyst, and like in case of agriculture, I said you have this geospatial analyst as well. And researcher, of course, it's a good field to research. Okay, coming to the career paths, which is similar to system engineering, or and system similar to aerospace system engineering, they are space. So basically, you have the same principles of system engineering, which is going to be used here. So it is space and automotive, military defense, transportation, like even rail is a very good example. So smart cities and energy. So based on these career paths which I showed you for aviation, you might get an idea for the career paths even in this. It's most likely going to be similar. And how do you prepare for a career in this? So this is lastly, I would just want to give you some quick tips. So if you're a student, I would encourage you to start and have an LinkedIn profile. Have an active one. So just keep up to date with the latest trends and keep looking out. Follow people who are like influencers or who post updates about your field or topic of interest. Attend webinars and podcasts, listen to podcasts, pursue small projects in the interested topics, because you have time and you can focus on these topics right now, so that later on, if you want to build on that, it would be very useful. You can also get involved in research projects, um, or participate in competitions, like which would also encourage you to take up that topic further. So, lastly, these are my contact details. So, I'm available on LinkedIn. You can send me a connection request. I also write a newsletter called Cosmic Signature, where I post mostly about space and aerospace and systems engineering. And this is my email. So you can also send me an email in case of any queries.